More than 1 million students are taking admission in computer engineering every year. But only few thousand are getting placed in their dream companies. So what do you think? What is the reason behind this? Actually, this is all about consistency and step-by-step guided preparation. I'm happy to announce you that iNeuron is coming up with DSA Foundation Course specially curated for product-based companies. So if you are targeting for Mang companies or any other product-based companies, please join this free course. For more detail, check out the description. The classes will start from 24 Jan, 5 p.m. Best of luck. Hello everyone. Welcome back to the DSA Foundation Course, specially curated for product-based companies. So if you are preparing for Mang companies or any other product-based company, this course will definitely will help you people. So, okay. And who can get benefited from this course? So if you are a beginner, then you can take this course, because in every lecture we are starting from very basic. Okay, for every topic we are starting from very basic, even from definition. And if you are an advanced learner, you are also welcome, because we are covering the product-based company problems in every lecture. You can check out previous lectures also. And if you want to switch from product-based software service-based company to product-based company, then again you are welcome to this course. Okay. And if you want to skill yourself, if you want to really skill yourself, if you want to make yourself recession proof, then this course will definitely help you. Okay, so good evening everyone. Please confirm me before proceeding on. Please confirm me if I'm properly audible or not. Bharat, Bhushan, nice to see you back. Good evening. Hello Mandeep, nice to see you back. Good evening. Okay, maybe I'm waiting for my other students actually who are joining every class. Meanwhile, okay, let me tell you the people who are new here. Let me tell you, this lecture is not a stand-alone lecture. Okay, this is not a stand-alone lecture. This lecture is the part of complete DSA series. This lecture is a part of complete DSA series, and we are going to cover tree today. Tree is one of the more important topic. People feel this topic tough, but I will try to make this topic easy for you people. So at least if you're not going for very high packages company like Google and all that, then this lecture will be more than sufficient for startup companies who are also paying good packages. This lecture will be more than enough, and this will build the base for the Mang companies, this lecture itself. Okay, so if you are new here, let me tell you, this lecture is the part of a complete DSA series. Okay, but you don't need to worry. If this is the first lecture you are attending, it's okay, you can attend that, because I will start from definition, what is tree, and then we will solve the product-based company problems. So I will give you the information, then we will solve the problem. Don't need to worry at all. If you are new to this topic or complete DSA, it's okay, and just join this session and enjoy it. Okay, and you can attend actually, because we are going to start from very basic. Otherwise, let me show the complete list. Let me show you the complete list of this series, this DSA series. Today we are going to cover our 15th lecture, tree, but we have already covered 14 lectures, starting from motivation to study DSA, time space complexity, asymptotic notation, mathematical problems, arrays, matrix, bitwise operator, recursion, searching, sorting, list, linked list, hashing, stack, queue. We have already covered till 14th lecture. So if you have not taken that, go to the description, find out the link, and just subscribe to this this course. Actually, this is free of cost. Okay, just you can subscribe, click on the link and subscribe to this course, and you will also get certificate. If you are completing all the videos, then you will also get certificate to complete this course. And believe me, you will really find out this course helpful for you. Okay, believe me, you will really find out. Okay, so let's start with today's topic. So I bring one tree also with me. although this is not a binary tree, this is a n-ry tree. Today we will focus more on the binary tree. Okay. So let's start with the tree. Hello Divya, nice to see you back. Hello Satish, nice to see you back. Okay, so today's session is about tree. Start with the definition. We are not going to start with directly from the problems. We will start from definition, so that if you are a beginner, you can also enjoy the session. You can also learn from here. You can also think, okay, up to how much level the product based companies are asking the question. You can also see that thing starting from very basic. So okay, let's start with the definition of the tree. Again, the same thing means whenever I write the definition, I write the some important properties. I write the important property of that thing in 1 or 2 lines. Here in 1 line, I try to put some important properties. Like a tree is a non-linear, one property. A tree is non-linear data structure. A tree is a hierarchical data structure, 2 property. A tree is a non-linear and hierarchical data structure consisting of collection of nodes, such as each node of the tree contain a value and a list of reference. So like this node, you can see each node is having a value A, B, D, C, E. These are values. This is data. We use the data structure to store the data only. So this is also a data structure. Tree is also data structure. We are storing some data in this. Yes, we need. That's why we are using the data structure. Just storing the data in different formats. So here we are storing the data in hierarchical format. Because in real life we find out that okay, there are many applications where we need to store the data in hierarchical format. Like if we talk about any organization, if you want to maintain the data of organization, then you start from CEO. After CEO, there remains the branch managers. Then you can say that sub branch managers. Then you can say that okay, team leads. After that, okay, maybe software engineers. So there is a complete hierarchical structure is there, and the family tree is also there. If you are building the softwares, then this can help you. This data structure can help us to maintain this type of data easily. Okay, because the data is in the form of hierarchical. Okay, and every node here is storing a value. Every node is storing a value and a list of reference. See, this part is storing the address of left side node. This part is storing the address of right side node. Every node is doing like this. Left part is storing the address of left node. Right part is storing the address of right node. Okay, and this cross is showing that okay, there is no left and right child. There is no left and right child. Fine, this is the definition. That's it. So definition says that this is a non-linear data structure. It's not a linear like array, means data is coming one after the another. Who is saying that okay, B is coming? Who can decide means which data will come this side? Maybe a tree can grow anyway. This is also a tree. This can grow like this also. This can grow like this also. I don't know. This can be a dancing tree also. Like this is dancing. This is a dancing tree also. I don't know in which way you are storing the data. That is not linear. Just like array. In array, the data is coming one after the another only. That is stored in consecutive memory location even. Okay, but here we don't know actually. Data can be anyway. The tree can grow anyway. Okay, see this tree is, I don't know how this tree is growing up. This look like Henry tree, but this don't have any child. Fine, okay. So this is the definition, means a tree is a non-linear data structure. Non-linear data is not in linear, one after the another is not coming. And this is a hierarchical data structure. Yes, grandparent. This is our means Dadaji. This is our father and uncle, you can say. And these people are us actually. Okay, these people are us. Fine. Okay, this is hierarchical, and every node you can see is having a value and a list of references. So this is a binary tree. In the case of ternary tree, there will be 3 reference. In the case of fornary tree, there will be 4 reference. So just we mentioned list of references. So here right now we have two list. One is this, one is this. And there may be 3 also in the case of ternary. Fornary 4, fivernary 5, nry n. Okay, fine. Fine, okay. So this is the definition. That's it. So let's see the applications also. Let's see the applications of the tree. So here is the applications of the tree. Let me show you. Let me move my cursor to the screen. Then I move the keyboard. So operating system, file system, like we have C drive. In my computer, if we talk about Windows, in my computer we have C and D drive. In C drive, further we have folders, So our file system, operating system, file system is designed. There also we are using a tree data structure. To maintain it, we are using tree data structure. Binary search tree is one of the famous search tree. Lots of questions are there in binary search tree. You can check out. Min heap and max heap is also popular data structure. Actually, that take constant time to find out the minimum and maximum element. B and B plus tree are used for DBMS, database management system, for efficient operations. Spanning tree is like a finding minimum cost spanning tree. And any organization chart, if you want to maintain the data of organization. Compiler also use any compiler also use C compiler, C++, Java, Python. Or they also use the syntax tree to check the syntax. Is your syntax is right or wrong? They use the syntax internally. So there are many other applications of the tree. Okay, so these are basics of the tree. So we now know what is definition of the tree, what is the structure of binary tree, and some of the applications we see. Fine, okay. Let me add more information in this. Let me add little more information over here. Let me add more information like these nodes, this, and this. These three are known as leaf node. These are known as leaf node. What are leaf node? Let me give you the definition. I will use these keywords like leaf node, non-leaf node. What is leaf node? The node which don't have any child, which have zero child. Okay, so the node which have zero child, those are leaf node. Okay, end nodes. Divya is asking one question. Compiler use stack or tree, sir? Compiler, see, I think you are confused with the recursion. Recursion use the stack. Recursion use the stack, and recursion use the stack data structure. I think you are asking about the recursion. Compiler actually makes the syntax tree. Compiler internally, there remains 6 phases in the compiler. Then you will see that, okay, the second phase of the compiler is the syntax analyzer phase. In syntax analyzer phase, actually the tree, the tree is made up, like a syntax tree is made up. So I was talking about that thing. Fine, okay. So just I'm telling you, these are the leaf nodes which don't have any child, which further don't have any child. And these 3 nodes are known as non-leaf node. These are known as non-leaf node. These are non-leaf node. This one, and this one. These are non-leaf means which have at least one child. See, this node have left child. This node have 2 child, left child, right child. This node also have left child, right child. So if at least we have one child, then those are known as non-leaf node, or also known as internal nodes. These are also known as, these 3 are internal nodes. Okay, and these are leaf nodes. So these are just some terminology which we will use while we will solve the problems. You can ask me anything. If you are finding something new over here, you can ask me that thing. Otherwise, I'm just telling the basics till now. Now, let's go for the tree traversal. Okay, let's go for the tree traversal. So there are 3 methods to traverse the tree. Don't worry about that person. Look at here. Look at here. So there are three type of traversal. One is pre-order traversal. We want to traverse the tree. We want to traverse all the nodes of the tree. Okay, maybe we want to print the data. We want to print the data at all the nodes. We want to print the data on all the nodes. Okay, so don't look at Bharat. Please look at here. Don't look at there. Okay, please look at here. So we can traverse the tree by pre-order traversal, or by in-order traversal, or by post-order traversal. So there are three methods. There are three methods through which we can traverse the nodes of the tree. So these are the three methods through which we can traverse the tree. Okay, so let's traverse the tree. Let's go through all the nodes. Let's go through all the nodes. Don't worry about this person. He is also trying to traverse. I don't know why he has taken so much serious. So, okay, let's talk about all of these three. Pre-order traversal, in-order traversal, post-order traversal. Before moving on, let me see how many people already know about them. Let me see. Okay, can you tell me, okay, in pre-order traversal, what is the sequence? What is the sequence in which we visit the nodes? Like, what is the sequence? We'll visit left first, right first, or we visit the parent node first. So in which sequence we visit the nodes? Can you tell me? In the case of pre-order traversal, let's see how many people know. If you know, you can reply. If you don't know, then just enjoy the lecture. If we don't know anything, we can enjoy. The people who don't know anything, they just don't need to worry at all, because they don't know, it's okay. Then we can enjoy. Anybody can reply. What is the sequence in which we traverse the nodes? So the sequence is like this. Let me tell you. Okay, Divya already tell us. Okay, top to bottom. Okay, Mandeep is saying top to bottom. Divya is saying left, right, parent. Okay, let me tell you. In pre, and the name is all itself is saying pre. So in this actually we will first visit the parent node. First we will visit the parent node. Okay, and then we will go to the left side of the tree. Then we will go to the right side of the tree. So in order traversal, we will first go to the left side. Then we will visit the parent node. Then we will go to the right side of the tree. In post-order traversal, first we will go left, then right, then we will visit the parent. So you can see here, when the parent node is visited, this is deciding, okay, the name of these traversals. So if you are marking, if you are saying that, okay, I'm saying that parent node, I will mark the parent node first, then I will go left and right. Then you are using pre-order traversal. If you are saying that, okay, first I will go to the left. After going left, and there is no more left, then you are marking the parent node as visited, and then you are going to the right side. Then you are using in-order traversal. And if you are visiting the parent node after going left and right, both sides, then you are using post-order traversal. Okay, fine. So let's see, you can try. If you already know about this, how to find out the traversals, if you already know, you can tell me. You can tell me what is the pre-order. What is the pre-order traversal of this tree? What is the pre-order traversal of this tree? Can you tell me? Is there anybody? Bharat, I'm just saying that. Let me repeat the thing. Please ask me. Whenever you need, please ask me. So that is the best way actually. Just don't hesitate and ask me. Okay. So whenever in the pre-order, we first visit the parent node, then go left and right. Okay, let me try over here. So I'm writing. We need to just traverse the nodes. Nothing. I don't know why they are making so much drama over here. We just need to traverse these nodes. We need to print this data. 50, 17. This data we need to print. So there are three methods we can traverse this tree. These are the three methods. Let's see about the pre-order. Pre-order is saying that the moment we started from here, root node, okay? The moment we see the parent node, mark it as a visited node. So we visited the 50. We visited 50. After that, this is saying that go to the left. So we come to the left. We come to left. After coming to left, again, see, at every node, you need to check this thing. Node, left, right. So node, already you already print the node. You already print this data. Fine, okay. After coming here, again check. NLR. So again, whenever you see the N, print this data. Whenever you see the N, print the data. So I'm printing the data. Fine, that's it. After that, okay, where I need to go? I need to go to the L. So here also you come to the L actually. When you come to the L, left side means, L means left side. Again, at every node you need to do like this. Node, left, right. Node means parent node. Moment you see node, you can mark it visited. So let me mark it visited. So I'm traversing, that's it. This is one way to traverse. First I traverse 50, then I traverse 17, then I traverse 9, go on. So is there anything left? No, there is no left then. There is no left. Is there anything right? Yes, there is right. So we come to right. After coming to every node, repeating everything, I'm repeating everything same. I'm coming to one node and checking these three things. So whenever I'm at the N, I'm marking it visited. Marking it visited means I'm printing it. Okay. And after that, I'm going to the left. Yes, there is something at the left. After coming to new node, again the same thing, I'm writing NLR. So N means print the node, N means print this node. There is nothing to the left of 12. There is nothing to the right of 12. It's okay. Then go back. From where we come? Actually, we come from the 14. So we already gone to the left side. Let's go to the right side. There is nothing to the right side of 14. There is nothing to the right side. So let's go back to the 9. So 9 also we have done all these three. NLR. So go back to the 17. So left already done. Let's go to the right of the 17. Right. We come to the right. This is the new node. Again right. NLR. Again right. NLR. The moment you see N, print it. Print this data. Mark it visited. Okay. Now you need to go to the left. So this is the method they are following in pre-order. First you mark the node and then go to the left, then go to the right. So I'm following that thing at every node. That's it. Coming to the left, NLR. At this node also, again, we are at the N. So print it. Okay, I'm printing it here. There is no space further. Fine, okay. There is nothing to the left of the 19. There is nothing to the right of the 19. So go back. Here R is left. R is left. So right side nothing. Go back. All NLR is completed. This arrow is showing. I'm making an arrow to indicate that, okay, how much we have covered. So left is already covered, right is not covered. So we are going to the right. This is a new node. Again, we are checking NLR. So we are starting from the N. The moment we are at the N, we will print it. We will mark it visited. And then we are going to the left. Yes, there is a node at the left. When you are at the new node, again, I'm repeating the same thing. Why? I don't know why I'm repeating the same thing. So when you are at the N, you print the node. Whenever you are at the N, we print the node. Can we go to the left? There is nothing to the left. So let's go to the right. Yes, there is at the right something. So again, NLR. At every node, at every new node, I'm writing NLR. I'm asking what I need to do. And he's saying that print the data. And he's shouting on me. He's saying that whenever you see me, just print the data. And he's saying that go to the left. Please go to the left. Well, if I can go to the left, we are going to the left. That's it. Again, NLR. And we go to the N again. The moment we go to the N again, now this time, and start crying. Why and start crying? Because every time he's repeating the same thing. He's saying that whenever you see me, just print it. Why are you asking me again and again? Just print me. This is the way we need to print this is the way we need to visit these nodes. And after that, nothing to the left, nothing to the right. So go back. Nothing to the right over 72. Go back. Back. That's it. So this is the pre-order traversal. This is the pre-order traversal of this tree. That's it. This is the pre-order traversal of this tree. That's it. What you don't know, Thomas? This is the pre-order traversal. This is the pre-order traversal of this tree. That's it. And you can do that thing in place of this. In place of this, we can put LNR. We can put LNR. Okay, let me repeat this thing again, but with the help of LNR. Let me perform in order traversal. And I will do the same thing actually. I will do the same thing. So let me erase this thing. Let me erase. If you don't understand, it's okay. We have still one more chance. We have one more chance. Let's print the in order traversal. Let's print the in order traversal of this tree. The same method I will use, just I will use this format. I will say that first I will go to the left, then I will print the node, then I will mark it listed, then I will go to the right. Earlier I was first marking it listed. The moment I see N, I will mark it listed. The moment I see left, I will go to the left. The moment I see right, I will go to the right. So here I will follow this method. And this is known as in order traversal. So first we are going to the left. So let's come to the left. Again, right LNR. Again you have mark it left. So again coming LNR. Again left. There is nothing to the left. So let's print this node. Because we are at the N, print this node. This is the in order traversal we are doing. That's it. In order traversal. So now after printing it, let me go to the right. Yes, we can go to the right. Right again LNR. LNR. So can I go left? Yes, we can go left. There is a node at the left. LNR. Can I go left? No. Can I print it? Yes, you can print it. Who is stopping you to print it? Who is stopping it to mark it wasted? Can I go right? There is nothing to the right of 12. So let's go back to the parent node 12. We are now at the N. The moment we are at the N, we will mark it wasted. We will print it in the output. And checking for the R, there is nothing to the R right hand side. Going back, all three covered. Going back, okay, mark it printed. Moment we are at the N, mark it wasted. That's it. That's it. And can I go right? Yes, we can go right. So right L and R. The moment you see a new person, okay, the moment you see a new girl, immediately you start going to the left. Immediately you start going to the left. And then if you find someone else also again you start going to the left. And the moment you find there is nothing there, you start approaching. You say that, okay, let me print you first. And after that, okay, there is nothing to the right. No need, then there is nothing to the right. Let's go to the parent. We are at the N. Print it. Right, nothing to the right of the 23. Come back to the 17. Then come back to the 50. We are at the N. Print the 50. Going to the right. LNR. Can I go to the left? Yes. Can I go to the left? No, there is nothing to the left. So print it then. There is nothing to the left. Can I go right? Yes, you can go right. LNR. Can I go left? Yes. LNR. Can I go left? No. Can I print it? Yes. Who is stopping? Print it. Can I go right? Yes, there is nothing. There is nothing to the right. If you want to go, you can. Otherwise, there is nothing. So 72, come back. Print it. The moment we are at the end, we will print it. Can I go to the right? Nothing to the right of the 72. Go back, print it. Print the 76. And after that, okay, there is nothing to the right. And then go back. That's it. So this is the in order traversal. This is the in order traversal. Do you get it? Do you get it? If you really get it. If you really get it. If you really get it. Can you tell me the post order traversal of this tree? Can you tell me the post order traversal of this tree? Can you write in the chat box? Let's see how many people can write. Vishal, nice to see you back. Great. I think you joined the last lecture. Also, you can complete the complete series. So tell me what is the post order traversal. Try the post order traversal. You are very good at traversal. I know you people, I don't know right now you are studying or not, but you always traverse. You always traverse behind the girls. I watch many times to you people. Thank you so much. Bisal is saying thank you so much for following the girls. Vishal, are you okay? Find out the posterior traversal. Don't think about the other things. Check out here. What is the posterior traversal? Please write in the chat box. Everybody, please write in the chat box. Please write in the chat box what is the posterior traversal. Whatever is coming to your mind, don't need to worry. Don't need to worry. We are not here to give the right answer. We are here just for trying. We are here just for trying. The moment you will try, learning will happen. The moment you will try, learning will happen. So please try and reply. Satish, come up with the posterior traversal. Satish, come up with the posterior traversal. That's great. So let me erase my screen meanwhile. So if you are trying, you can try. Okay. If you are trying, you keep trying, please. If you want me to wait, I can wait. Also, you can mention that thing. Otherwise, let me tell you one shortcut also. Let me tell you one shortcut through which you can find out the in order, pre-order, post-order traversal. Okay, you can find out that. So if you are trying, you can try. That is more important. So let me write pre-order, in order, and post-order. So let me write pre-order, in order, post-order. Actually, so I'm sharing right now. I was thanking you, and when you say welcome back, Vishal, you are lying. I know you are lying right now. Okay, so if we are starting from the 50, if we are starting from, see, at every node of the, this is a binary tree. Okay, this is a binary tree. You will visit, confirm, that is confirm. You will visit every node 3 times. Okay, you visit every node 3 times. So the moment you will visit a node first time, okay, you will write it into the pre-order traversal. The moment you will visit a node second time, the moment you will visit the node first time, you will write it in the pre-order. The moment you visit second time, you will write in order. The moment you visit third time, a node, same node, third time you are visiting, then you will write in post order. Okay, so you start from here. You visited your girlfriend first time. Okay, the moment you visited, you mark it here. You say that, okay, pre-order, that is pre-order traversal. So again, you are visiting your first time, you are visiting your girlfriend 17. Moment you are visiting first time, you will put it in the pre-order. Then again, next node is this. See, make this if any node don't have the left child or right child, make a dummy node. Make a dummy node. So I'm just telling a shortcut to find out in order, pre-order, and post-order traversal. Okay, you can use that also, so that you do not need to be worry about the other stuff. So you can easily find out very fast way actually. So this is a very fast method to find out in order, pre-order, and post-order traversal. So I'm going through. The idea is simple, is like that. If you're visiting a node first time, you will place it in the pre-order traversal. If you are visiting a node second time, you will place it in the second order traversal. If you are visiting a node third time, you will place it into the post order traversal. So first time visited, put it pre-order. First time visited, put it in the pre-order. Now second time we are visiting the 9. First time we visited here, second time again we are visiting the 9. Second time visiting 9, so put it into the in order. Now first time we are visiting the 14, put it in pre-order. First time pre-order. Second time in order. Third time, 1, 2, 3. Third time we are touching the 12. Post order. Second time in order. Third time, post order. Third time, post order. Third time, post order. 1, 2, 3. You see, third time I'm visiting the 9. Second time I'm visiting the 17. First time I visited here. Second time I'm visiting here. So every node we will visit 3 times because this is a binary tree. Okay. So 17, second time. So second time in order. Second time you're visiting, put it in the sequence of in order. First time pre-order. First time 19 pre-order. Second time 19 in order. Third time 19 post order. Second time 23 in order. Third time 23 post order. Third time 17 post order. Second time 50. First time here, second time here. Second time in order. First time 76. First time. Second time. First time. First time. Second time. Third time. Second time. Third time 72. Third time 54. Let me write over here. Second time 76. Third time 76. And third time 50. That's it. So this is the sequence in which we are visiting all the nodes. This is the post order sequence. This is the in order sequence. This is the pre-order sequence. Okay. So this is the one shortcut. The shortcut is like that. You are visiting the tree, like going through all the nodes and coming back. And while coming back, going from this side, left side, and after visiting and coming back, if you are visiting a node first time, you are placing it in the pre-order. If you are visiting a node second time, you are placing it in the in order. If you are visiting a node third time, you can place it into the post order traversal. So these are the different way to traverse all the nodes. That's it. These are the different way to traverse all the nodes. These are the 3 methods to traverse the nodes. That's it. We are just, the motive is we want to traverse the data, all the data. So these are the 3 way we can traverse the data. Managed way we can traverse the data. Fine. Okay, fine. I hope this is clear to you people. Otherwise, if still there is any doubt, it's okay. We will implement it. This problem you can find out on the lead code. If you will write binary tree pre-order traversal. Okay, what they have done, they have provided a root node of a binary tree, and they're asking, can you please return the pre-order traversal of all the nodes? Can you please return the pre-order traversal of nodes values? Okay, let me show you the problem on lead code. So yeah, here is the pre-order traversal problem. Okay, let me rub it. So here is the same problem, binary tree pre-order traversal on lead code. You can find out this problem. Okay, and here what they have provided, if I show you, see they are saying that this is the function we need to complete. Actually, we need to code the pre-order traversal. Okay, and they are saying that they are providing us the root of the tree. Whenever we need to pass the tree, we do not pass the complete tree. We just pass the root node. From the root node, we can access the other elements because we have the left child and right child address. Just like if you are passing the linked list, means if I give you the linked list means I'm giving you the head of the linked list. I'm not providing the complete data. I'm just providing the head of the linked list, not LinkedIn. I'm just providing the head of the linked list. Okay. Okay. Yeah, LinkedIn also works like that way. Fine. Okay. And in tree also, we just provide the root. In tree also we provide the root. We just provide the root node, and the complete tree is passed away. What we need to do, this is our resulting vector, means array. If you don't know vector, it's okay. This is the array in which we need to store the result, the sequence in which we are visiting all the nodes. We are calling this pre-order traversal function. We are calling this function pre-order. We are passing the root node. We are passing the tree root node. We are passing the this array, resulting array, in which we will store our result. And after that, okay, we will return our resulting array back. So we are calling this function, and we need to perform the pre-order traversal. We need to perform the pre-order traversal. At least we know what is pre-order traversal. We can solve this problem actually very easily. We can solve this problem very easily using the recursion. Using recursion, we can solve it very easily, because if you notice, when I was finding the pre-order and in-order traversal, at every node, every node I was writing like this. At every node I was checking these three things. The moment I was at the parent, I was printing it. The moment I was at the left, I was going to the left tree. The moment I was at the right, I was going to the right tree. And I was doing this thing at every node. At every node, I was doing the same thing. So because you're repeating the things, you're repeating the same thing again and again. So we can use the recursion. Even before that, okay, can you tell me what is the pre-order traversal of this tree? Please write in the chat box. Please write in the chat box. Keep trying. Don't sit idle. See, if you will sit idle, your kids will also sit idle. And they can ask you, Papa, you do not work. You do not study at all. Why are you asking me to study? They can ask, they means they have logic with them. They're the child of the engineers. They have the great logic than we people have actually. So let's save the next generation. Please keep replying. Okay. So yes, Divya, you are right. Yes, Thomas, you are right. The output for the pre-order traversal of this tree is actually 1442. Yes, you are right. So if you know the logic also, then you can share the logic. Yes, Satish. Yes, Vishal, you people are right. Can you share me the logic also? Otherwise, see, at every node what we are doing. Let me write a function, pre-order function, in which I am passing the root node. I'm passing the root node. So what I'm checking, okay, I'm doing 3 steps. First step, what I need to do in the pre-order, we are actually, I can write, okay, mark, first step, mark visited parent node. First thing we need to do this. We know that this is the way we need to traverse. NLR. N is the parent node, then left, then right. So first step is the mark the parent node visited. Fine. This is how pre-order traversal works. Second step, then go to the left side, left subtree. So we will call this same function pre-order traversal. We will call the same function, but we will pass the left subtree. We will pass the left subtree. That's it. So we call this same function, rather than the parent node, root node, we have passed the left subtree node, left subtree parent node. Okay. And after that, after passing the left subtree, then we will go to the right subtree. So we will call this function again, pre-order root of right. That's it. That's it. So 3 steps are there. And again, this is going to the right subtree. And at right subtree, again, we need to do the same thing. So that's why recursively I'm calling the same function. Because at the right subtree, at going to the right subtree, again, I'm checking this NLR. Every time I'm checking NLR. So that's why we can use the recursion for the left subtree, for the right subtree. That's it. That's it. So any doubt you people can ask in this? Any doubt in this you can ask. So Divya is asking something, I think. Bishal, you are right. This is NLR. and print. No, in the pre-order, yes. Okay, Mandeep, I'm coming to that also. In the second point is not printing the parent. In the in order, you will do like that. In the in order, you will print the parent after going to the left. In the in order, we will use this method. First, we will go to the left, then we will print the parent node, then we will go to the right. But in the pre-order, we first print the parent node, then go to the left tree, right tree. Okay. One more thing Mandeep want to add me. Mandeep is saying that because you are using recursion, so you need to write the termination condition. Otherwise, you will get stuck in an infinite loop. So yes, let me write one termination condition also over here. So this is our first. Let me write termination condition. So if I can write if root is null, when the root will be null, then we will return. We will say nothing to do, just return. Else, if root is not null, then I will execute these three codes. Is that fine? Mandeep, is that fine? So I added the termination condition also. And because we are using recursion, termination condition is must. If I will not write termination condition, then we will get stuck in infinite loop. So infinite steps we will get stuck actually. Okay. So this is the termination condition also I have added. Fine. Okay, let's code it now. It's very easy to code. It's very easy. This question is asked in so many companies. I don't know people why they ask this question. This is so much easy. It's so much easy to code. So okay, let's code this function over here, pre-order. They provide us the tree root of the tree. They are providing a resulting array. We need to store the result into this resulting vector. Rather than printing the result, we will store it into the resulting vector. Okay, so let me write it here. First, let me write the termination condition itself. I'm just copying, pasting the same thing what we have discussed. I hope the screen is visible properly. I'm increasing the font a little bit more and moving this side. Yes, I think that will be visible. So now if the root is null, then you are saying me, if the root is null, then there is nothing to return, just return. Else, if root is not null, then we will perform three tasks. First, because this is pre-order, in pre-order that will be NLR. Whatever will be the first node, we will store that into our resulting vector. We are not printing that. We are storing that into this resulting vector. We need to store in a vector, in an array, and we will return that. Okay. So let's store that. Rather than printing, we store that. So this is our resulting vector, res. There is a function pushback. Pushback function is there with the vector through which we can add the element. So we want to add the value at that particular node. So we add the value. This is the n part actually. This is the n. And after that, we need to go to the left subtree. So let's call this function again. This function pre-order function. Let me copy paste it. Because I need to call it recursively. Let me copy it. And I'm passing the root, comma, resulting array. So two things are required. One is resulting array. Two parameters are here. Resulting array and the left subtree root. Okay, left subtree we need to pass. So root left we pass. That's it. And similarly, we will pass the right subtree, pre-order, and root right, comma, resulting array. That's it. Done. That's it. So let's execute it. Let's submit it. Yeah, it's working fine. There is nothing any big thing in this. That's it. This is the code. That's it. Any doubt in this? Any doubt in this? So if there is nothing, if there is root is null, then we do not need to return anything. We are storing the value. We are storing the value into the resulting vector rather than printing it. This is our n, this is our L, and this is our R. Right side, right tree we are visiting. Right tree we are visiting here. Left tree we are visiting here. And before that we are printing the node at which we are printing the value of that. That's it. Okay, and the same code, let me show you in Java first of all. So this is the same code. Okay, little change is there. We in place of these are the three conditions, means we are adding the value into the array list, we are performing pre-order, and we are performing we are going to the right side. So rather than arrow operator, we are using dot operator. Okay, let me write it the same way what previous code is written. So we can write it. So we can write if the root is null. So in Java we use small null. Okay. In C++ we write that in capital. Little syntax difference is there. That's it. Otherwise the logic is the same. Return in, and otherwise we are coming to the else part. Else we are executing the same thing. That's it. The same logic, same everything, and let's submit it. Yeah, it's working fine. And Bharat Bhushan is asking the code in Python also. So here is the Python code. The same thing, means we are appending. We are using, in the place of array, we are using a list over here, and we are calling the pre-order traversal function this, and three tasks. Three are the three steps are there. Same three steps are here. First one is storing the result, marking the node visited. After that, going to the left of the root, then going to the right of the root. That's it. Same. Just the difference of the syntax. That's it. Bharat Bhushan. Is that fine? And we can move on. Okay. Let me show you the other traversal. So this is the second program now. Binary tree in order traversal. So if any doubt in previous one, you can ask me. Any doubt in previous one, you can ask me. I'm going to the PPT back. So what the time complexity actually for this is order of n, because we are visiting every node one time. And the space complexity will also be n. Why the space complexity is n? Here we are actually, one thing is that, okay, it's not about only the resulting array we are using. It's not about that only, but because we are recursively calling, and in the worst case, your tree can be like this. If the tree is like this, then you are recursively calling. You are calling from here to here, here to here, here to here, here to here, here to here. Okay. So when you are recursively calling, then these function 1, function 2, function 3, this will go into the stack. 1, 2, 3, 4, 5, 6, all 1, 2, 3, 4, 5. All these function will go into the stack. This stack will be maintained by the CPU. Okay. And this is taking how much space? Order of n. Order of n space this is taking. Okay. Although we can reduce this space to constant by solving this problem using the loop. We can solve the same problem using a loop also. That is your homework. Okay. To solve the same problem using loop. Right now, okay. Can you tell me? So pre-order done. Pre-order done. If you don't understand, it's okay. The same thing we will do in the in order. Same thing, just the formula, little formula is changes. L and R we are using here. First we will go to the left, then we will mark the node as printed, then we will go to the right. Okay. Now, please first of all tell me what is the in order of this input. First of all, please everybody write in the chat box. Time complexity, Divya, for the loop, it's order of n. Time complexity is order of n. Space complexity, you can bring it to constant. In the if you are using loop for traversing the array, traversing the tree. Okay, fine. Okay, please tell me what is the in-order traversal of this. What is the in-order traversal for this tree? Please write in the chat box. Don't sit idle. Don't sit idle. You know the consequences of sitting idle. Don't sit idle. Already the next generation is very, they are means very clever. Those people are very clever, believe me. So Mandeep is saying that that will be 4, 4, 2, 1. The same thing is shared by Divya and Satish. Let's check out if this is our in order or not. Let me check out the answer. Where is my mouse? Yes, that is 4, 4, 2, 1. Okay, how we will solve this problem? This is the way we need to traverse. So I can write like in order root I am passing. Okay, let's suppose the resulting array also I am passing. After that, if root, this is a termination condition. If root is null, then return, nothing to do. If root is null, then there is no node at all. Then what you will do? There is nothing to traverse. Otherwise, come to the else part and traverse in this format. First, go to the left subtree. So I am calling this function again in order, and I am going to the left of the root, and passing the resulting array also, because we need to pass 2 parameter. So I already gone to the left. Now we print the node. Print the node means okay, I can store the result in resulting vector. So there is a pushback function. So let me tell you people, I'm coming after this week. This week we will complete the DSA Foundation. Next 2 week I will come up with a new series. So please join that series. The series is Mastering C++ STL. We will learn the C++ STL libraries. Okay, so like I'm using here vector. This is a vector. I'm using this function pushback. So learning all about the STL. We will cover the complete STL. Again, we will cover the complete STL, but our target again will be the product-based companies. Okay, we will solve again the product-based company problems in that series also. From next week, so I'm coming up with the C++ STL standard libraries series, in which not C#, C++ standard libraries series, in which we will check out the vectors, stack, queues, sets, unordered set, map, unordered map. All these we will discuss. Yeah, after that, yes, Bharat, you are right. After that, after this C++ Mastering C++ series, then I will come up with in-depth DSA. After, in between, there will be a gap of 2 weeks. To fill this gap, I seen this in this series that okay, people don't know actually about the C++ STLs. So we can finish that. We can master it in just 2 weeks. So let master that also. So when we will go to the in-depth DSA, then that will be easy for me to use the sets, unordered set, map, unordered map, multi-map, multi-set. So all these inbuilt functions like queue, stack, dequeue, all that we will cover over there in these 2 weeks, next 2 weeks. And after that, if you will ask me again, I will say, please go to that series that is already on YouTube. Go to that series, then come back. Okay, so that we need to go to the advanced, then we will not come back to the basic. Okay, then we will not come back to the basic. So I'm covering C++ STL series from next week. I'm coming up with that. Okay, be there everyone. Fine. Okay, So just this is the same. This is the same. Why I don't know why we are writing this again and again. So these are the three steps. One is L, one is N, one is R. So L, call the left side. R means store the result. Root value we are storing. Whatever is the value, we store that into our resulting vector. Now we call the function for the right. In order root right. That's it. Done. Finish. Khatam. That's it. So let's code it also. Any doubt in this, you can ask me. Any doubt is coming to your mind, please don't hesitate to ask me anything. If you want to discuss with me, we can discuss over here. Otherwise, okay, I'm coding the same thing. This is in order. Okay. And this is our resulting vector. This function is called over here, and we are passing the root and resulting vector. So whatever will be the resulting vector, whatever will be the result, we will keep storing in this array, and then we will return this. So simply we need to code here. Fine, we know the formula. Let me write here L and R. This is the way we traverse in the in-order traversal. So according to that, let's code it. Very easy. So I'm writing the termination condition first. If root is null, then return. The root is null, तभी भाग जाओ बस, साथ के साथ run away. If the root is null, we don't need to do anything. Otherwise, we need to go to the left side. So I'm calling this the same function recursively. Let me copy. So copy paste is our best friend actually. So I always try to copy and control C and control V. Best friend of the software engineers. So root left. We are passing root left, and we are passing the resulting. Where is our resulting? Here resulting array also we are passing, because here two parameters we are passing. One is root, one is resulting array. Fine. We have gone to the left. Now let's store the result in our resulting array. Res dot pushback. So whatever is the value at the root, we just store that into resulting vector. So this is our N, you can say. And after that, we are going to the right. We will go to the right. So I need to call it recursively, this function. So let me copy paste it over here and pass the two parameters. This time I'm passing the right side link, and the resulting vector also we need to pass. That's it. So this is our R, L and R. That's it. Done. Let's submit it. Let's submit the code, and it's working fine. It's accepted. The answer is accepted. Fine. Okay. And any doubt in this, you can ask me. So Bharat Bhushan is asking how this will help. Okay, next series if you are talking about. Bharat, how, that is nice question. Why you are asking, why should I have to attend the next series? I'm a Python programmer. Okay. So Bharat, there will be one benefit. We will be solving again product-based company problems. So I will not touch the Python, okay, because that will be C++ based completely. So still, if you are interested, you can join, because I will be covering product-based company problems, but you need to solve them in Python yourself. I will not provide the code, because this will be C++ specific. Okay, because the name is itself mastering C++. So I don't want to divert to other languages. Okay, I cannot make it multilingual, because we are learning language only. Mandeep. There is one question Divya is asking. That's a nice question actually. Let me highlight it. In product-based companies, C++ is given priority, or Python. It's no language is given priority. The logic building is given priority. If we are providing the solution in pseudocode, Believe me, 101%, 200% they will hire you. 200% if you will write the code in pseudo code, they will hire you. 101% because they know that logic building takes time. Logic building takes 6 months to 2 years, depending upon how serious you are, depending upon कितनी आपको जरूरत है. जितनी आपको जरूरत है उतना ही आप एफर्ट डालोगे. ठीक है, तो जितना हाउ मच एफर्ट यू विल पुट, बेस्ड अपॉन दैट either you can complete, you can learn the DSA in 6 months also, and you can learn in 2 years also. So 6 months to 2 years that will take, and there is no priority to any C++ and any Python and any Java. This is just a one language, and you can learn the language in 1 month. You can learn the language in 1 month. Just complete Tamil. Divya is asking Tamil. So you can also maybe, okay, I will also teach in Tamil, then let me see if how much you can understand. Maybe I can use Chinese. So what about if if your interview don't know the Chinese and you are telling, okay, I will tell in the Chinese. So it's better you use the pseudo code. See, pseudo code is a mathematical way. So if he don't know about C++, Java, Python, if you are providing the logic in pseudo code is accepted all around the world. Either that is Chinese, either that you are going to USA or Germany or anywhere you are going. Either you are going to even to the Pakistan also, they will also accept the pseudo code. Okay, pseudo code is accepted everywhere. Pseudo code is a just mathematical way to write the code, and maths is the international language. Everybody will accept that. Fine, okay, let's move to our code. No specific language need to know for product-based company, that is sure. But it's better you build command on any one language. Okay, just take any one language. It's like language is just like language. Means you need to convey your message. You need to convey your message. To convey your message, you need to know one language. And you can use pseudocode also. That is also fine. That is also fine. Fine, okay. So we're done. We're done with the pre-order, in order. Yes, we're done with the in order. We're done with the in order traversal. Fine. Let's go now back to the third one. So we're done with the in order also. Now let's go with the post order traversal. Now let's go with the post order traversal. Post order traversal. Post order traversal, left, right node. That's it. Left, right node. So many companies asking that these basic questions, and we can answer means them. Okay. People even don't know how to traverse the tree. So they expect means these things very. Okay, this comes in very starting in the tree actually. Okay, and they're asking, these people are they're asking from here itself only. Okay, fine. Can you tell me what is the post order traversal? What is the post order traversal of this? Please write in the chat box. Please write. Please keep trying. You need to see. You need to reply. If you will not reply, then actually this will be really difficult to connect. Right or wrong doesn't matter. That should not matter in class. That should not matter in class. Please go to, if you are studying right now, and please go to your class and say to the professor, right and wrong doesn't matter. Just blindly stand up and say right and wrong doesn't matter. Even he is not asking. Just say this thing. Okay. Convey this message to him. Okay, let's see what is the post order traversal. So 4241 is the post order. Because we are using this method, left, right, and node. So we are going to the left, we are going to the left. There is no more left, there is no more right. So visit this node, then come back. Left already done, so come to the right. No more left, no more right, mark it visited. Come back. No more left, no more right, mark it visited. Come back. Left is done, right is nothing, mark it visited. Yes. This is the post order traversal. Otherwise, you can do that with shortcut also. If you want to use shortcut means the third time you are visiting a node. The third time you will visit every node 3 times. The moment you visit a node third time, you will put it into the post order traversal. Okay, first time visited, first time visited, first time, second time, third time, second time, first time, second time, third time, third time, second time, third time. So this is the, you can use shortcut also if you want to find out, okay, what is the pre-order traversal or any order traversal, you can find out. Fine, okay. So let's try to code it. Very easy to code. The same thing. The same thing is there. Let me show you the coding screen. I'm going to the coding screen, and here is the same program you can find out on lead code. I am just taking these problems from lead code, and here the same thing they are providing us. You can see they are providing us resulting vector. They are calling a function recursively post order. Here this function is called, and the final result we will return, which is stored in this resulting array vector, whatever you can call. We need to code over here. We need to just again write the same line, just the format will be this LRN. That's it. So let's do it. Let's do this also. Let's finish this also. I'm writing the termination condition. First of all, if root is null, then just return, do nothing, return. Else what we need to do, first we need to go to the left. So let's go to the left. So let me call this function recursively. Let me copy paste this function over here, function name, pre-order, and I'm going to the left side of the root. I'm going to the left side, and I'm passing the resulting vector also. After that, I will go to the right side. So I'm calling the same function for the right side of the root, for the right side, and passing the resulting vector also. And after that, okay, store the result into the resulting vector, push back. Push back. So root value, store it here. That's it. Done. Done. Let's submit it. Yeah, it's working fine. Same thing, just we just change the sequence of these three lines. And if you go to the Java, this is the again the Java code. You can see little here we are using array list in place of the vectors, and in place of the arrow operator we are using dot operators, because we don't have array inside the Java. And here also we are using the dot operators, and in place of array we are using list in Python. This is the Python code. The people who are in Python. Fine. Vishal is asking, can we make GUI in C++? Yes, you can make, but right now you can make, yes. Actually, if you will find out, if you are using this Windows is written in C++ only. Okay, Windows is written in C++. So Windows is a great GUI only, graphic user interface. Okay, so yes, you can make, and that is faster actually. C++ is faster, but Python providing various functions, and other languages are there. If you want to build up other type of game building, then other type of softwares are coming actually for game building, game specific, if you are talking about. But we can build in C++. That is tough, no doubt, but they are faster. Your Windows itself in C++, and your Linux and which one is the another one, Unix, is in C language. They are in C language. So yes, we can make the GUI. But if you're talking about games, then we have other, you can search out, it's better to go with other languages. Fine, okay, this is the post-order traversal. Fine, done. Let's go back to the PPT. Done with this now. We're done with the basics. Now let's move to the main problems. Let's try to solve some of the problems. and we might fall like this. Don't worry, it's okay. We are starting, so that might happen. But here is the Google problem for you people. Please try. Please try. That is important if you are trying or not. Right or wrong doesn't matter. Right or wrong doesn't matter. Please try and reply. Everybody, don't sit idle. Don't sit idle. Don't worry. Right or wrong doesn't matter. Just tell me what is the function of this code. Please tell me what is the function of this code. Please tell me. So let me give you the brief idea. This is the binary tree. Okay, this is related to binary tree. We are passing the root of the binary tree. Okay, and we are calling this function actually. See, this fun function we are calling recursively here and here. 2 times we are calling this function. One is for the left subtree, one is for the right subtree. Root right, root left. Okay, and we are adding 1 in this, and total value we are returning. So this is the means idea. Means we are calling this function 2 times. We are passing the root of the binary tree. What actually this code is doing? What actually this code is doing? Can you tell me? We are not making pre-order traversal. We are not doing pre-order traversal. Just you can dry run. You can dry run and you can check out. Please dry run and check out. The moment I will get one answer, I will move on. The moment I will get one answer, I will move on. Let me see if anybody can tell me the right answer for this question. There are many problems related to this problem. There are many problems related to this same problem. We will solve the same problems, similar type of problems here. Okay, so please try and reply. Okay, let me, if you are trying, fine. I'm making just dry run. I'm not telling you what this code is doing. I'm just making a dry run on this tree. Let's suppose I'm passing this tree. Okay, I'm passing the root node, fine. Root is not null. This is not null. There is data over here, and this is also have left child and right child. This is not null. This is null. Okay, this is null. This is null. This right side is null. Here both left and right side is null. But root is not null. Root is not null. So we come to the else part. I'm just making dry run. I'm not telling you the solution. If you know, please write in the chat box. What happens when we call this function? When we pass this root node and call this, we come to the else part, and we call the function. First, we call the function for this. Here, we are performing what we are doing. We are adding 1. We are adding 1, and we are calling this fun function for the left and for the right subtree. Okay, we are doing this thing. We are executing this statement for this root node. After this, okay, we call this function, means we call the same function for this node, for the left node. This function I'm executing. This function will also is not null. This is not null. So this will also execute this statement. So I'm writing 1 plus function. I'm not writing fun completely. Fun of the left plus fun of the right. This will also execute this statement. And its left function again will be called. This left function will be called. And this is not null. This has the data. This is not null. So this will also execute 1 plus fun function of left plus fun function of right. Now this will again call this function fun for the left, but left side is null. This time the value we are passing is null. There is nothing. This is null. This course is showing null. So this, when we call this function, we will get stuck inside this statement itself, because root will be null. We are passing null over here. null. So this will return from here itself. So this is returning 0. What I'm saying, this is returning 0. Similar, the right side is also null. We will get 0. We will return back from here itself, because now this time this is 0. So 1 plus 0 plus 0 is pass away to this. Means this function was called over here, and from here we get 1. 1 plus 0 plus 0, 1 we get. Its right side is null. Right side is null, so this will return 0. So when there is a null, that is returning 0. So this is 1 plus 0. So this is returning 2. This is returning 2 over here. We are going to the right side now. For right side also we will do the same thing. 1 plus fun of left, fun of right. Okay. And now we are coming to the fun of left. This will also do the 1 plus fun of left, fun of right. Fun of left side is null, so this will return 0. Right side is null, this will also return 0. So 1 plus 0 plus 0, this will return 1 total. 1 plus 0 plus 0. So here we get 1 for the left side. For the right side, again, this will call the function. This function will be called, will pass this node. And because this is not null, so we will come to the else part. And this will also call fun of left and fun of right. And because left side is null, this will return 0. Right side is null, this will return 0. So 1 plus 0 plus 0, this will total return 1. This also returning 1, this also returning 1. 1 plus 1, 3. So here we get 3. Okay. So now root is what? Root is returning 1 plus 2 plus 3, 6. This is our result. What we are getting, I just make dry run. I just make dry run over here. Again, I'm asking the same question. Again, I'm asking the same question. What is the function of this code? What is the function of this code? I just make dry run right now here. I just make a dry run. Can you tell me? Can you tell me what is the function of this code? Please reply. What is the function? Function I'm talking about. I'm not asking about the what this is returning. Yes, this is returning 6. What that 6 is? What actually this function is trying to do? Yes, Divya. Yes, Satish. You people are right. We are counting the number of nodes. This code is counting the number of nodes. You can see easily actually. You can see it very easily. How? How you can find out? See, 6 nodes are here. 1, 2, 3, 4, 5, 6. You can see easily from this code also. If some node you are passing, for every node, you are calling this function for every node. You are calling this function for every node. And for every node, you are adding 1. For every node, you are adding 1. And if there is no node, then you are adding 0. If there is no node, left side no node, right side no node, right side no node, left side no node, right side no node. There is no node, then we are adding 0. Otherwise, we are calling this function for every node. And for every node, we are adding 1. That's it. So this is just adding 1 for every node. So this is counting how many nodes are there. This is counting how many nodes are there. Yes. Yes, you people are right. Yes, Thomas. We are counting the number of nodes in a binary tree. In a binary tree, we are counting number of nodes actually. So if you really understand, let's see if you really understand or not. Let's check out that thing. Think over it again. Okay. Think over it. I'm asking you another question. You need to think. If you really want to be good at DSA, you need to think. It's all logical. Can you please answer me this question? Can you tell me what is the function of this code? Please think. Please think and reply. What is the function of this code? Little bit change is there. We added this statement. This is new thing here. And we have removed +1 from here. Okay, we have removed +1 from here. So can you tell me what is the function of this code? Please check out. Please think. That is the learning if you are thinking or not. That is the learning part if you are thinking or not. Knowing the solution will not work. If you are directly jumping to the solution, let me tell you, you are wasting the question. You are wasting the question if you are directly jumping to the solution. If you're thinking about it, learning happening. Please think. These are the places where we want to go. Ola is famous for 1 CR. Ola is famous for 1 CR. These are the places we want to go. So there is no magic. You need to know. You need to solve these questions. You need to solve these questions. Please think about it. Please think about it. Please reply and think. What do you think? What can be the function of this code? Yes, you can make dry run also. And Divya, your dry run is right. Okay, we get one answer at least. After making dry run, Divya is coming up to the answer that this will return finally 3. Yes, Divya, you are right. What is this 3? What is this 3? What this 3 is denoting? Yeah, many answers we get this time. Kavya, new person, Kavya. Welcome to this series, DSA series. So you can check out similar lectures. This is a complete series. This is not the only lecture of tree. Let me tell you, this is the complete series. Go to the description and you can register for this course for free, and you will also get certificate. Okay, go to the link and register over there. You will find out other lectures also very interesting. Believe me, you will find them interesting. Yes, you are right. Yes, Kavya, and yes, Satish. Yes, Divya. Yes, Thomas, you people are right. We are, yes, Mandip, we are finding leaf nodes here. We are finding leaf nodes here. See, you can see from the code itself. You can see from the code itself. If the left side is null, if at every node, if any node, left side is null and right side is also null, both are null. If we don't have any child, left child and right child, then only we are counting. Then we are returning 0. Then we are returning 1. If left child is also null and right child is also null, then we are counting this node. Then we are adding that. Then we are counting it. Then this is returning 1. Otherwise, this is returning 0 or doing nothing. This is not adding anything. This is not doing nothing. It's just adding 1. It's returning 1 every time. It's finding a leaf. What is the definition of the leaf? Leaf, in the leaf, there is no left child, there is no right child. There is no left child, there is no right child. This is not a leaf because this have the left child. So even if you have a one child, that is not a leaf. You should not have both. Both are null. Then we can say that, okay, that is a leaf. And we are counting that. Otherwise we are not counting anything. We are not adding 1 anything over here. Yes, you people are right. We are counting the number of leaf nodes. And if you really understand, if you are really understanding all this stuff, if you are really understanding, so let me ask you one more question related to this. First of all, okay, you people are right. We are counting number of leaf nodes in a binary tree over here in this code. Let me ask you another question. Can you answer this one, please? Can you modify this code? Can you modify this code? Can you modify this above code to count number of non-leaf nodes? I want to count number of non-leaf nodes. This code is for counting leaf nodes. Can you make some changes over here? You need to make some changes over here. Can you make some changes over here so that you can convert this program to count non-leaf nodes? Please think about it. Can you make modifications over here so that this program, this function start counting number of non-leaf nodes? So non-leaf nodes are the nodes in which we have at least one child. So this is also non-leaf node. This have one child. This have two child. This is also non-leaf. This have two child. This is also non-leaf. So can you please convert this code? Can you tell me what is the modification we can make? Whatever is idea coming to your mind, you can share. Whatever is coming to your mind, just share. Don't need to worry about the right or wrong. And you should not worry in the class. Class is not for checking the right or wrong. Exam is for checking right or wrong. When you will go to the interview, then okay, right and wrong will matter, but not in class. In class, learning should matter. And the moment you try, learning happens. That's it. The moment you try, learning happens. You just keep replying whatever is coming to your mind. You just keep replying, just checking yourself. That's it. I will keep taking your answers. Please reply. Please think. Whatever is coming to your mind. Don't need to worry about the answers. So we get some answers. Let's see from Divya. We are getting answer. Divya is saying, first let me take the answer from Divya. The same answer is, I think, shared by the Satish also. Okay, Divya is saying that rather than writing null here, not equal to here, he's asking me write not equal to. And Satish is also saying write not equal to. Just they are asking me just replace this equal to with not equal to, not equal to. Okay, I'm doing this. I'm checking it. Okay, is this working fine or not? I hope they are trying to do what they are trying to say that okay, if if left side it is not null and right side is also not null, both are not null. If both are not null, then we will consider it. But what about this node? What about this node? In this, both are not null. This is only one is null, another one is not null. So this is an internal node. This is the non-leaf node. According to your condition, this node is not satisfying. Why you are not counting this node? You're not counting this node. You're not counting this node. Okay, there is a little modification from Divya's side. Divya is saying that it's okay. Why are you shouting so much? No need to shout. Just replace this and with or. He's asking me, will please replace this and with or. Okay. So if we replace this with or, this code will not work fine. There is some problem in this. If we replace this with or, still there is some problem in this. Mandeep is also saying replace with or. Kavya is coming up with something different. In the else part, Kavya is saying, okay, Kavya, I'm coming to your answer. Kavya, I'm coming to your answer. Before that, I'm taking Mandeep answer. Okay, I'm coming to your answer. So Mandeep, see what is the problem that will happen here. Divya, what is the problem? See what the problem. If I'm doing like this, not equal to null, not equal to null, and or is there. Okay, fine. See what the problem will happen. The problem will happen here is that we'll start from the root. See, we are starting from the root. We pass the root node. We pass the root node here. That is not null. That is not null. Okay, we come to this condition now. Is this condition satisfied? Yes. Left side is not null, right side is not null. Immediately you return. Immediately you return 1 from here. You're not going down. You're not going left and right. You're not coming to the else part. You're not coming to the else part. You just return from the root itself. Your condition is satisfied for the root and you just return from the root itself. You're not coming to the else part. You're not coming to the else part. Are you understanding? Are you getting? Yes, but still you are thinking. That's great thing. Means learning is happening. Believe me, the moment you think learning happens, The moment you think learning happens. Okay, one last answer I'm taking from Kavya. Actually, Kavya is coming up with the right answer. And Kavya is saying that just replace this 1 with 0, replace this 1 with 0, and here add 1. What she is trying to say is that for every node add 1, for every node add 1, except those nodes, except the leaf nodes. For every node add 1. This is the same thing what we were doing earlier when we were counting all the nodes. This was the thing not there, this was the not only thing, this statement was not there, otherwise the code is same. What Kavya is saying, adding 1, when we are adding 1 means we are counting every node, but by adding this statement we are returning from here itself. Moment we see the leaf node, this statement is making the confirmation for the leaf node. So the moment you see the leaf node, if left is also null, right is also null, then we return 0. So the moment we are looking at the leaf node, we are returning 0. Okay, it's executing like this. So we are calling the fun function over here. This is not the null, and this is also not satisfying this. So we are coming to the else part for this. So we are going to the left, plus we are adding for the right. So we are coming to the left. This is not null. So left plus right. We are coming to the else part for this node also. For left, left and right. Fun of left and fun of right. Now the left is null, so we are returning 0. This is returning 0. Oh, sorry. Even this will not go further actually. When we will come at the leaf, when we will execute this part, this left part, we will return from here itself. Because its left is null, right is null, this will not go further. This will return 0 from here itself. And we get 0 from here also we will get 0 for this. 0 plus 0, this will return 0. And from this side, f of L, f of R, this will return 0. This will return 0 because of this code. Because of this code, this will return 0. This will also return 0 because of this code. So 0 plus 0. This is also returning. Sorry, we need to add 1 also. 1 plus 0 plus 0. 1 plus 0 plus 0. 1 plus 0 plus 0. So 1 plus 0 plus 0 is 1. So we get 1 plus 1 here. And from here also 1 is coming. So 1 plus 1 plus 1, 3. 1 plus 1 plus 1 is 3. So yes, the idea is simple, is that we will count 1 for every node except the leaf nodes. Except the leaf nodes, or for the null part. Fine, that's it. So yes, you are right. Just replace this one with 0 and add 1 here. Kavya, you are right. Yes, this will work. Now we count no leaf nodes, internal nodes. We just make 2 modification. Replace this one with 0 and add 1 here. That's it. Fine. I hope everybody get it. I hope everybody get it. Let's move on. Let's move on. Any doubt you can ask me. Any doubt you can ask me. Otherwise, let's move on. Any doubt you can ask me. Otherwise, let me take another question. So this is from D Show. Let's first of all, okay, tell me the output. Check out the question and tell me the output for this input. Please tell me the output. Everybody, please try this. Please tell me the output. What should be the output for this input, for this tree? What should be the output? Please write in the chat box. Please reply. That is important, if you are replying or not. That is important. Yeah, but how much is the depth? So okay, yes, Divya, yes, Mandeep, you people are right. We need to find out the max depth of binary tree. What is the max depth? So they have given the definition of the depth itself. The maximum depth is the number of nodes along the longest path from root to the farthest leaf. So this is the longest path from the root to the, this is the farthest leaf. This is also a leaf, but this is closer to the root. This leaf and this leaf are the farthest one. So this is the number of nodes from root to the farthest leaf. How many nodes are there? 1, 2, 3. So the depth of this tree is 3. The depth of this tree is 3. Okay, but let me tell you, okay, this I just take this question from the lead code. Okay, but according to Corman book, which is the Bible for algorithm, Corman book, this is not the definition of the depth actually. This is not the definition of the depth. Depth for this tree should be actually 2. It's not the number of nodes from root to the farthest leaf. It is the number of edges. It's the number of edges according to Corman book, which is the Bible for the algorithm. That should be 2 actually, but okay, this is what is given in the lead code, so we need to follow according to them. So they are saying that they just give us the definition. Okay, they say that this is the definition, you please follow this thing, you please follow the definition of this depth. Okay, so okay, let's follow this. And depth we will consider, okay, number of nodes, not number of edges. So for this we need to return 3, not 2. Okay, Divya, I think you were telling 2. So this is not 2 actually. According to, yes, the real definition means I will follow the Corman book because that is a Bible for the algorithm. So according to that, the output should be 2. But okay, they provide us the definition. So let's follow this definition and let's try to code this problem. Let's try to code this problem. Any idea how we can solve this problem? Any idea how you can find out the depth of this tree? How you can find the depth of this tree? Any idea you can share in the chat box? Anything coming to your mind? Means you starting from the root node and you're going down. Anything coming to your mind? Okay. And just finding number of nodes and return. Cover actually that will not work, and the reason is that they will, okay, Cover is coming with good answer actually. So let me share with you people. Counting number of nodes and taking the log, that might work in the case of complete tree. Complete tree, they do not mention that the tree is complete. They do not mention this is a okay, this itself is not a complete tree because in the left side there is a blank space over here. So this is not a complete tree. Okay, you can say the height is log n, still the height is log n. Your method can work, but in the case of complete tree, they don't mention they are providing us the complete tree. The height of complete tree is log n. Yes, you are right. The height of complete tree is log n, but this is not a complete tree. Okay, so they don't mention this is a complete tree. Maybe the tree can be like this. A tree can be like this. Okay, so now you cannot say that the height is log n. The height is itself, how the heights depending upon number of nodes. 1, 2, 3, 4, 5, 6, 7. Whatever is the n value, that is the height. That is the height according to this definition. Okay, that is the height. That is not log n. That is not log n. Log n will be approximately 2. Log of 7 will be approximately 2. So this is not a complete tree. For complete tree, might be your answer can work. Any other idea? Keep sharing, keep sharing. So one is from Mandeep. Mandeep is saying that, okay, traverse the tree Okay, one idea I'm sharing from my side. Mandeep, check out this thing. So I need to find out the maximum depth. So what I can say is that, okay, I'm standing over here. I'm saying that, okay, I will see, is this part, is this left subtree is giving me the maximum height, or the right subtree is giving me the maximum height, right subtree. So simply I can say that if I'm standing over here, can I write like this? I will say that, okay, this will be my result. I will return this thing. I will say this. I will say that, okay, I will count this node. This node I will count 1 plus. I will check out. What is the height of left subtree. Okay, so let me find the height of left subtree, and I'm finding the height of right subtree. So I find out the height of left subtree and height of right subtree. I'm saying that I will consider the one which is having the max height. I will consider this one is having the max height. This is having 1 and 1, 2. This is having 1. Okay, we can solve this problem recursively. At every node, after coming at every node, I will see what is the height of left subtree, what is the height of right subtree. Which one will be having the max? I will consider that only, because I need to find the maximum distance from root to farthest leaf, that can be anywhere, either to the left or either to the right. So every time I'm checking at every node, what is the height at left side, what is the height at right side. So I can put it inside a recursion. At every node I'm checking this thing, whichever will be the maximum height, we will take that one, and one for that node, one height for that node. That's it. Okay, let me try to code this thing. Let me try to code the same thing. So I'm going to the lead code, and here is the same problem you will find out on the lead code. I have taken this problem from here itself. You just write maximum depth of a binary tree in Google, and you will find out this problem on lead code. You can try over here. So simple. The idea is that, okay, return. What we need to return? We will take max of. Okay, I'm calling this function again recursively, max depth, but for the left subtree, root left. Okay, and I'm calling the same function again for the right subtree, root right. Okay, so whichever is the max, we are taking that, plus we are adding 1. Okay, and because we are using a recursion, okay, we need to write the termination condition also. So if I can write, if my root is null, then there is no height. There is no height. Then if root is null, okay, then we can return. If root is null, then there is no height. We return 0 height. Else we can execute this. Part. That's it. And let's submit this code and check out. Yeah. I think let's submit this. So just it's working fine. It's accepted. And what we have done, nothing. Just we are finding, okay, out of left subtree or out of right subtree, which one is the max, which is returning max. And at every node we are adding 1. We are adding for itself also. And after that, okay, we put one termination condition. Or you can say that if there is nothing, there is no root node, or root node is itself null, then tree is not there. Then we will return 0. Height is 0. Height is 0. Fine, that's it. What is the time complexity for this? If anybody can tell me. What is the time complexity? What is the time complexity over here? What is the time complexity? Time and space complexity, if you can tell me. Time complexity and space complexity, that's it for this code. Divya says order of n. And because we need to go through all the nodes. At every node, you are executing one statement. This statement you are executing at every node. Okay, you are performing one max operation at every node, and you are performing one addition operation. 2 operations you are performing at every node. If n nodes are there, at every node you are performing 2 operations, max and plus. So constant operation you are performing at every node, and n nodes are there. So total complexity is n into 1, that is n. So this will take n time. And what is the space complexity, if you can tell me? Space complexity. Kavya, expecting from Kavya. What is the space, or other people can also reply. What is the space complexity? Time complexity is n, because at every node we are going and checking, do you have any left child, left subtree or right subtree? Which one is the max we are checking? So yes, Mandeep, you are right. Yes, Divya, you are right. The space complexity is n actually, yes. And the reason you must be knowing, due to recursion. We are not using any extra data structure here, anything, but you are calling recursively. You are calling this thing, these are recursive calls, and this might happen that, okay, your tree is like this, then all these nodes, function 1, function 2, function 3, all this will go into the stack. So this stack is maintained by the CPU. We are calling recursive. We are calling recursively these. Okay. So the maximum height of this stack can be n. Okay, or you can say n minus 1. Last function will not go into the stack. Okay, you can say n minus 1. So space complexity is n. Extra space is taken due to recursion, and that maximum can go to order of n. And in the case of complete graph, that can go, space complexity can go log n, because the height will be maximum log n. Okay, fine. Okay, so let's move on. Let me share my PPT back. Oh, that's it. That's it for today. Thank you everyone. This is the last thing. Okay, so we will meet tomorrow with the graph. I hope you enjoy this session. I hope you learn from this session. So if you really find this session helpful, don't forget to write in the comment section after this session and give a thumbs up. Okay. So this should reach to maximum students. This is your responsibility also. This is your responsibility to help other people also. Okay. Okay, then otherwise, thank you everyone for joining. Anything if you want to discuss with me, I'm here. Still we have time with us. 2 minutes I will wait here. If anything you want to discuss with me about your career, about this series, about the next series. So the people who are joining right now, Bharat Bhushan is saying, I love your memes. Okay. So that's great. So this is just to add little fun over here so that we don't feel bored. Divya is asking B tree and B plus tree is important. B tree and B plus tree are not asked in the DSA. In DSA, nobody asks. If somebody want to take the interview of the DBMS, then that is important. In DSA rated interviews, nobody asks from B and B plus tree. Mandeep says excited about your next series. So let me highlight this thing. So let me tell you, if you are right now joining, let me tell you, after next week we are coming up with mastering C++ again for product based companies. Okay, C++ in C++ I'm not going to cover the very basics, means you must be knowing the variables, loops, functions. I'm not going to cover that. We will cover the STLs, standard libraries of C++. We will cover, like we will cover vectors, we will cover pairs, we will cover unordered set, unordered map, map, multi-map, multi-set, set. All these inbuilt data structures we will study. Okay, and other functions are there. We will study the different algorithms also. So 2 weeks we will complete cover up the C++ STL, and you will feel comfortable after that. Thank you everyone. Now I'm winding up this session. Thank you. We will meet tomorrow. Bye bye. Take care. Good night.